Ratin Schentwinsen Vagoton Tubes 19 und 19 und 50 sagen.
Mitte alți mit septembrie spate gemoiat.
Sputnik is real. Humanity has entered the space age.
Overnight, humanity's relationship with the sky changes forever. Space is no longer an unreachable mystery. It has become a destination waiting to be explored. The achievement leaves little opportunity for celebration. Deep inside Soviet-designed bureaus, an urgent directive arrives, demanding another unprecedented mission within only a few weeks.
We have weeks, not months. Failure isn't acceptable.
The next spacecraft must launch before national celebrations begin, despite impossible engineering deadlines facing every designer. The compressed schedule eliminates any possibility of designing a spacecraft capable of safely returning to Earth. Survival during launch itself becomes the immediate engineering priority. Despite overwhelming challenges, the mission's objective remains unmistakable. For the very first time, a living creature must travel beyond Earth's atmosphere and enter orbit successfully. Scientists confront profound uncertainty.
We don't know how life will respond in orbit.
Maintain normal breathing, or endure the violent transition into orbital space. Every crucial question remains unanswered. Will the heart continue beating normally? Or will the unfamiliar environment make orbit deadly? Before meaningful scientific observations can even begin. The only path toward certainty is remarkably simple, yet deeply consequential. Humanity must send life itself into space and carefully observe what happens beyond Earth. Across the frozen streets of Moscow, technicians quietly begin searching for suitable candidates, focusing not on laboratory animals, but resilient stray dogs hardened by survival. Years of enduring freezing winters, hunger, heavy traffic, and constant uncertainty have made these small stray dogs exceptionally resilient, perfectly suited for the demanding experimental mission. Their compact bodies also satisfy another essential requirement. Every kilogram saved increases the rocket's chances of successfully reaching orbit, with its precious living passenger aboard. Among the collected animals is a calm, mixed-breed female, with bright, alert eyes, remarkable composure, and an unusual ability to remain still in unfamiliar surroundings. She has known only Moscow's unforgiving streets, navigating cold pavement, passing strangers, scarce food, and countless narrow escapes that quietly shaped her remarkable resilience. Soon she receives a new name, Laika, meaning barker. History, however, will remember her not for barking, but for answering humanity's greatest unanswered scientific question. Laika's mission will carry her into the silent darkness above Earth's atmosphere, where no living creature has ever ventured, and no certainty yet exists. Training begins immediately, with no luxury of gradual preparation. Every remaining day becomes precious as scientists race relentlessly against an unforgiving political deadline approaching fast. Small pressure chambers recreate crushing launch forces, while centrifuges spin relentlessly, preparing Laika for conditions no living creature has ever experienced before leaving Earth's atmosphere. Tiny habitat modules severely restrict movement for days at a time, conditioning the dogs to tolerate confinement inside a spacecraft barely larger than their own bodies. Every recorded heartbeat, measured breath, and observed reaction moves the impossible mission one step closer, transforming uncertainty into valuable scientific evidence for future exploration.
Theory ends here. Space will reveal the truth.
Every experiment becomes humanity's first encounter with an environment understood only through scientific theory. Veterinary specialists, physicians, and engineers work together tirelessly, converting biological uncertainty into measurable engineering data essential for understanding life in orbital space. Electrodes are carefully attached to Laika's body, while sophisticated sensors monitor her pulse, breathing, and blood pressure throughout every stage of the unprecedented mission. The monitoring equipment must survive violent launch vibrations and the harsh vacuum beyond Earth's atmosphere, demanding extraordinary reliability under conditions never previously encountered. Slowly, the spacecraft evolves beyond a simple machine. It becomes a carefully engineered laboratory, built entirely around the needs of one extraordinary passenger. Inside the workshop, time becomes the greatest enemy. Engineers work relentlessly, as precious hours disappear faster than new solutions can be completed and verified. Freshly fabricated metal panels arrive still warm, while wiring harnesses are installed before the spacecraft's final engineering drawings have even been completely finished. Some components intended for future inspection are permanently sealed, because reopening them would consume valuable time the mission simply no longer possesses. Each completed assembly solves one engineering challenge, while exposing another, forcing exhausted teams to balance innovation against unforgiving deadlines imposed from far above. Cooling systems must remove body heat from a cabin scarcely larger than a household appliance, while remaining dependable throughout the demanding orbital mission ahead. Oxygen generators must operate continuously without maintenance, supplying breathable air, while carbon dioxide is absorbed before reaching dangerous concentrations inside the confined spacecraft. Every engineering solution increases spacecraft mass, yet every additional kilogram threatens the rocket's ability to achieve orbit successfully, with its irreplaceable scientific passenger aboard. Unlike future spacecraft, Sputnik 2 is never designed to return safely to Earth. That reality remains unavoidable from the mission's earliest planning stages. The launch vehicle possesses enough power to reach orbit, but no available technology can perform controlled re-entry or safely recover the spacecraft afterward.
Its mission ends in orbit, but its legacy begins there.
Although deeply painful, the decision appears unavoidable. Gathering humanity's first biological evidence from orbit is considered essential before risking a human spaceflight mission. Beyond the design bureau, newspapers celebrate Soviet achievements with triumphant headlines, while hidden calculations continue deep into countless exhausting nights behind closed laboratory doors. Thermal engineers discover a troubling possibility. Once in orbit, parts of the spacecraft may absorb far more solar radiation than earlier calculations had predicted. If protective insulation fails to separate exactly as planned, temperatures inside the cabin could climb beyond safe limits, leaving almost no margin for engineering error. Despite the alarming discovery, there is no remaining time for a complete redesign.
We proceed. There is no time left to redesign.
As November approaches, the completed spacecraft begins its journey toward the Baikonur Cosmodrome, crossing the vast frozen expanse of the Kazakh steppe before launch. Before dawn, frost settles across the launch complex, coating the towering R-7 rocket with a thin layer of shimmering ice beneath powerful floodlights. Technicians climb towering service structures for final inspections, while electrical cables deliver power into the spacecraft one final time before departure from Earth. Deep inside the sealed cabin, surrounded by scientific instruments, Laika waits quietly, unaware she is only hours from becoming history's first orbital traveler. Within the tiny compartment rests humanity's greatest unanswered question, entrusted entirely to a small stray dog, whose remarkable journey is about to begin. The final countdown begins before sunrise on 3 November 1957, as anticipation spreads across the frozen launch site beneath the cold morning sky. Supercooled liquid oxygen meets the crisp air, producing immense clouds of drifting white vapor that gradually envelop the launch pad in thick mist. From afar, the rocket appears motionless and almost fragile against the endless horizon, concealing extraordinary power waiting silently within its towering structure. Up close, thousands of carefully assembled components stand prepared to ignite in flawless sequence, each performing an essential role during the historic launch. There can be no second attempt. The anniversary deadline has arrived, and the mission's outcome now rests entirely in the hands of physics. Inside the pressurized cabin, Laika is secured within a padded harness designed to stabilize her body throughout the violent acceleration of liftoff. Nearby, a dispenser containing nutrient-rich gelatin sits within reach, while ventilation fans continuously circulate air through the tightly enclosed spacecraft compartment. Telemetry systems begin transmitting a continuous stream of biological measurements, carefully monitoring Laika's condition long before the rocket leaves the launch pad. Inside nearby control rooms, oscilloscopes flicker constantly, as engineers observe every heartbeat and every breath arriving through the spacecraft's electronic monitoring systems. Even before liftoff, the spacecraft is already communicating, sending invaluable biological information from its lone passenger directly to waiting scientists below. Then ignition arrives, and the silence instantly disappears beneath the overwhelming roar of clustered rocket engines, unleashing unimaginable power toward the heavens above. The launch tower rapidly vanishes beneath an immense pillar of fire, as millions of newtons of thrust propel the rocket powerfully away from Earth. Relentless acceleration presses against every structure aboard, while violent vibrations race through metal frames, instruments, wiring, and Laika herself during the extraordinary ascent. For several intense minutes, every bolt, wire, instrument, and heartbeat is tested simultaneously, as the spacecraft climbs relentlessly through Earth's increasingly thinning atmosphere. Telemetry immediately reveals Laika's biological response. Her pulse rises to more than twice its resting rate under immense acceleration and violent launch vibrations. Her breathing becomes rapid and uneven, as overwhelming forces push her body far beyond anything experienced during even the most demanding training exercises. Despite the tremendous physical stress, the telemetry continues uninterrupted. The electrodes remain connected, and every critical instrument performs exactly as engineers had hoped. Most importantly, Laika survives the punishing ascent, providing the first evidence that careful preparation allows a living passenger to endure orbital launch conditions. One rocket stage separates, then another. With every successful event, the launch vehicle becomes lighter and continues climbing steadily toward orbital velocity. The surrounding atmosphere grows progressively thinner until aerodynamic forces disappear completely, leaving only the darkness of space beyond Earth's protective envelope. Outside the spacecraft, the sky transforms from deep blue into absolute black, not because night has arrived, but because the atmosphere has vanished. Then comes a moment no living creature has ever experienced before, a moment that forever changes humanity's understanding of survival beyond Earth. The engines suddenly shut down. Instantly, the crushing force of acceleration disappears, replaced by the extraordinary sensation of continuous free fall around Earth. Weightlessness is no longer a scientific theory debated inside laboratories. It has become a measurable reality experienced by a living creature for the first time. Telemetry records Laika moving inside the spacecraft, while her heart rate remains elevated, but gradually begins declining as her body adapts to microgravity. The measurements provide remarkable evidence that a living mammal can survive the transition into orbital weightlessness without immediate physiological collapse or fatal complications. Invisible radio waves carry these historic biological observations toward receiving stations thousands of kilometers below, where anxious scientists await every incoming transmission. Celebration erupts inside Soviet tracking stations as exhausted engineers embrace one another, recognizing humanity has crossed another extraordinary boundary in the exploration of space. After weeks without rest, their impossible mission appears successful, proving that life can survive reaching orbit and opening new possibilities for future human exploration. Yet while Sputnik 2 completes its first orbit above Earth, another collection of instruments begins reporting measurements that immediately concern mission controllers. The first warning seems minor. Cabin temperature increases only slightly, remaining comfortably within the predicted operating limits established before launch began. Engineers compare the readings against their calculations, fully expecting the spacecraft's environmental control system to stabilize the cabin without difficulty or unexpected complications. Instead, the temperature continues rising steadily, revealing that somewhere inside the hurriedly constructed spacecraft, the delicate balance of thermal control has begun failing. Tracking stations receive telemetry in brief intervals as Sputnik 2 passes overhead, forcing controllers to reconstruct the mission from scattered streams of incoming data. Each orbital pass lasts only minutes before the spacecraft disappears beyond Earth's horizon, leaving scientists anxiously awaiting the next precious transmission of information. The evidence remains puzzling. Oxygen continues flowing normally. The ventilation fan still operates, and Laika's heart continues beating despite rising cabin temperatures. Yet the thermal sensors refuse to stabilize. indicating that something beyond the spacecraft's life support systems is steadily driving temperatures higher with every orbit. The source of the problem lies outside the cabin, where part of the spacecraft's protective insulation fails to separate exactly as engineers intended. That unexpected configuration changes how sunlight strikes the spacecraft, and how accumulated heat radiates back into space, disrupting its delicate thermal balance. Unlike Earth, orbit offers no atmosphere to carry heat away. Warmth can escape only through radiation, a much slower physical process. The narrow engineering margin that once appeared acceptable on paper now disappears steadily, as every orbit exposes the spacecraft to relentless solar heating. Inside the cabin, biological instruments begin recording the consequences, as Laika's breathing, once gradually recovering after launch, becomes noticeably faster again. Her pulse climbs despite the complete absence of acceleration, revealing that rising cabin temperatures rather than launch stress now challenge her body's stability. As temperatures continue increasing, Laika struggles to maintain her normal internal balance, while the spacecraft designed to protect her becomes an unexpected danger. For Soviet scientists, the incoming telemetry is simultaneously heartbreaking and historically invaluable, revealing biological responses never before observed during orbital flight. The measurements demonstrate that launch stress, although severe, gradually subsides after reaching orbit, confirming weightlessness itself is not immediately fatal to mammals. Instead, the greatest danger comes from the spacecraft's failing thermal conditions, exposing critical engineering weaknesses that future missions would be forced to overcome. Beyond the Soviet program, none of these alarming developments are publicly known, as international radio broadcasts celebrate another remarkable technological triumph in space exploration. Newspapers around the world publish illustrations portraying Laika peacefully circling Earth, suggesting she remains comfortable inside an extraordinary masterpiece of Soviet engineering. Few people outside the program understand how experimental the mission truly is, or how completely impossible any rescue attempt would be in orbit. No spacecraft exists that can intercept Sputnik 2, and no technology yet allows an orbital capsule to safely return its passenger to Earth. Every passing minute carries Laika farther beyond humanity's reach, while scientists continue receiving the final scientific evidence her mission was designed to provide. After only a handful of orbits, environmental conditions inside the cabin deteriorate beyond recovery, bringing Laika's historic journey toward its heartbreaking and irreversible conclusion. The telemetry that transformed Laika into history's first orbital traveler also records the final moments of her pioneering mission high above the blue planet below. In silence, far above the world she once wandered as a stray, the mission fulfills its scientific objective, while exacting a profound and lasting cost. For years afterward, the world believes a different ending, as official Soviet statements describe Laika surviving several days before receiving a painless final meal. That account spreads through newspapers, documentaries, and history books, becoming one of the defining narratives of the early space age despite hidden telemetry records. Behind classified doors, however, the mission data preserves another truth. Concealed as Cold War priorities favor triumphant achievements far more readily than complete transparency. Even after communication ends, Sputnik 2 continues orbiting Earth, racing across continents and oceans at nearly 8 kilometers every second in lonely silence. The mission returns without dramatic photographs or film, yet its streams of telemetry forever reshape space medicine and guide the future of human orbital flight. Laika carried no flag and claimed no victory, yet her silent sacrifice forever changed exploration by teaching humanity the value of bringing every traveler safely home.